Okay, now for the engineering physics lab, the first activity is the force table. Okay, the force table. Okay, now for the force table, the composition of the force table. The force table illustrates the vector addition of forces. The composition of the force board consists of circular discs with its periphery slanted 10 degrees apart. The spring balances are provided to record the magnitude of the forces applied to the ring. They are connected one end to the ring and the other end to chain, the links of which fit into slots provided the disc. Now, the objective of the activity number 1 to study graphically and analytically the magnitude and direction of the resultant and the equilibrant of a set of concurrent of coplanar forces. Now, we have the value of your F1, which is equal to 100 grams, with theta 1 equal to 0 degree. Then, your F2 is equal to 150 grams with theta 2 equal to 80 degrees. If you notice, both forces are lying on the first quadrant. Why? Kasi both are positive. Remember from your physics lecture, we have your y-axis, the x-axis. First quadrant, you have your x and y. Always remember that going to the right is positive, going to the left negative, upward positive, downward negative. Therefore, the sign here of your x is positive and your y-axis here is positive. While for the second quadrant, okay, now for the second quadrant, we have the sign of your x as negative. Why? Because going to the left, while your y is positive. For the third quadrant, we have your x is going to the left, therefore negative. Your y is downward, negative. For the fourth quadrant, we have positive for x, negative for y. Now, since we have 100 grams and 150 grams, under the graphical method, using your ruler, draw your y-axis and x-axis. Then, okay, let us assume, this one is not a conversion, instead a ratio. We cannot use the ruler using the units in gram. Therefore, we have 100 millimeter is to 100 grams. This one is not the conversion. It's just a ratio assumption so that we can solve for the value of your resultant. Then, your 150 millimeter is to 150 grams. Can you follow? Can you
Yes
follow?
po.
Okay, now, this one will be the origin. Okay, from the origin up to 100 millimeters. Okay, you have now here, example ha. Okay, this one would be your F1. Then, using your protractor, measure 80 degrees. 80 degrees using your protractor, okay? Then, from this point, from the origin up to 150 millimeters, okay, this one will be your F2. Then, okay, again, measure 100 millimeters from this point. Okay. It should be parallel with your F1. F1. Then, measure from this point up to that point a value of 80 degrees. And then from this point up to that, it should be parallel with your F2, which is equivalent to 150 millimeters. That would be your F2. Can you follow? If this one is 80 degrees, what would be the value of this one? Okay. Therefore, that is what? 100 degrees. Remember, the whole is 180. Kaya we have 180 minus 80 is 100 degrees. From this point up to draw a diagonal from the origin up to this meeting place. That would be your resultant. Okay. And this one would be your angle theta for the resultant. Now, in solving for the resultant in graphical method, all you have to do is to measure from the origin up to this point. Okay, that would be the value of your resultant. Then, for your theta r, for graphical method, you're going to use your protractor. From the x-axis up to this point, what would be the value of your theta r? The value under the graphical method is 195 millimeters and the theta r is 50 degrees. Now, go back to the original units. Therefore, our r is equal to 195 grams. And then theta r is equivalent to 50 degrees. Under the equilibrant, which is found under the fourth table, since your R is lying on the first quadrant, therefore your equilibrant is lying on the third quadrant. Remember, according to the definition of equilibrant, the same magnitude as the resultant, but lying on the opposite direction. Therefore, the equilibrant is also equal to 195 grams, but lying on the opposite direction. Your theta R is 50 degrees. If this one is 50 degrees, of course, this one is also 50 degrees. 180 plus 50 is equal to 230 degrees. Okay. This one is 230 degrees. 180 plus 50, therefore that is 230 degrees. Now, you have the value for the graphical method for R, which is 195 millimeter. Then the true value is 195 grams. Since the ratio that we use is 100 millimeter is to 100 grams. Then you have to multiply the resultant by 980 centimeters second squared to get the value of your resultant. Okay, now for your resultant under the graphical method, we multiply over 195 grams into a gravity of 980 centimeter per second squared, which is now equal to 191 times 109. Remember, we use the value of your gravity as 980 centimeter per second squared since we use the unit of the mass in grams under the CGS. Okay, now for the second table, we have three values for the vector. F1 is equal to 100 grams and F2 is equal to 150 grams and F3 is equal to 100 grams. Okay, the angle, your theta 1 is equal to 0 degree. Theta 2 is equal to 80 degrees. And theta 3 is equal to 150 degrees. Okay, draw the figure. We have the y-axis, the x-axis, y and x. Now, from your x-axis, you have 100 gram. Theta 1 is 0 degrees. Therefore, this one is your F1. Okay, ratio again. You have your 100 grams is to 100 millimeter. 150 grams is to 150 millimeters. F3, that is 100 grams, is to 100 millimeters. Okay. From this point, again, measure 80 degrees. Okay, this one is your F1. F2. Okay, F2 from the origin, you have F2. Okay, 80 degrees. Then your F3, 100 grams, which is 150 degrees. 150 degrees. And therefore, this one is 150 degrees. If that is 150 degrees, of course, this one is 30 degrees. Okay, F3. Okay. Now, under the graphical method, okay, for the graphical method, you have your F1. Okay. Then draw your X and Y. Okay. X and Y. You have your F1 from the origin up to that point. Wait. Okay, from the origin up to that point, measure 100 millimeters. Okay, after that, again, draw X and Y from the head of the 100 millimeter. Okay, X and Y. Okay, and after that, okay, from this point, you have to measure 80 degrees. Since this one is lying on the first quadrant, 80 degrees. Okay, this one is 80 degrees. Then, you have from the head of the F1, measure again 150 millimeters. Example, this one is your 150 millimeters. 150 millimeters. Okay, that would be, this one would be your F1, F2. Then, from the head of your F2, again, draw your X and Y axis. Okay, if you notice, your F3 is lying on the second quadrant. Okay, from the point, from the origin, okay, measure 30 degrees since this one is 30 degree, or you can also measure from this point up to 150 degrees. Although 30 degrees. Okay. 30 degrees. Okay, this one would be 30 degrees. Okay. From the origin, measure 100 millimeter. Example, this would be your 100 millimeters. F3. Okay. From the head of your F3, connect it to the tail of your F1. Then measure your resultant. That would be your R. You're going to use your ruler in measuring the resultant. This one is called the Polygon Method, the head-to-tail method. Okay. And then, after using your ruler, you can find for the value of your R. Then, using your protractor, you're going to measure from your F1 to the resultant. That would be the theta of your resultant. Okay. Value of your R and theta R. Okay, now for the value of your R using the ruler, the value is 203 millimeter. Using the protractor, your theta is 78 degrees. Now, Go back to the original units. Therefore, the value of your R is equal to 203 grams. Multiply it to 980 centimeter per second squared, and theta R is equal to 78 degrees. Okay, therefore, the R is equal to 198,948 dyne, and theta R is 78 degrees.